The key to this problem is recognizing that all demands and capacities must be in terms of the same flow unit. As a result, since each of the products have different demands and activity times, you cannot express the flow unit as one product. One unit of product A has a different process flow than one unit of product B. Instead, we must express the flow unit as minutes of work available. Let's create a chart to look at the capacities and demand at each resource. At resource 1, there are 2 workers. They can each work 8 hours a day and 60 minutes an hour. That gives a capacity of 960 minutes per day. Since at resources 2 and 5 there are also 2 workers, we know at those resources the capacity is also 960. At resources 3 and 4, there's just 1 worker. So therefore, we have 1 worker times 8 hours a day times 60 minutes, or 480 minutes per day. Now let's determine the demand or workload of each of these resources. This problem states that demand is 40 units for product A, 50 units for product B, and 60 units for product C. Multiplying these demand times the activity times listed in the chart, we can determine the total demand at each resource. For example, at resource 1, it will take 200 minutes for product A, plus 250 minutes for product B, plus 300 minutes for product C. That's equal to 40 times 5, 50 times 5, and 60 times 5, the activity times for each of the products. That's a total demand of 750 minutes. Following a similar process, we can calculate the demand for each of the remaining resources. At resource 2, the demand is 620 minutes. At resource 3, it's 600 minutes. Resource 4, it's 330 minutes. And at resource 5, it's 900 minutes. With these data points, we can compute the implied utilization at each of the resources. And this will help us identify the bottleneck. Implied utilization is equal to demand over capacity. For resource 1, this would be equal to 750 divided by 960, or 78%. Following the same process for the remaining resources, we realize that resource 2 has an implied utilization of 620 over 960, or 65%. Resource 3 is 600 over 480, or an applied utilization of 125%. Then resource 4 is 330 over 480, which is an implied utilization of 69%. And finally, 900 over 960 for resource 5 implies an implied utilization of 94%. The bottleneck is at the resource with the highest implied utilization, which in this case is resource 3, with an implied utilization of 125%. Now, to calculate the flow rate for each flow unit, we'll take the capacity at the bottleneck and divide it by the activity times at that resource, which in this case is 15. That yields an answer of 32 products of type A, and keeping in the same product mix, that implies then that would be 40 products of product B and 48 units of product C.